Hello, everyone. Today is June 7th, 2025. This is day 4, week 9 of Hotel Evening Weekend Platoon. Today, we're going to cover database schema design, or should I say SQL schema design, because depending on what database you're using, the design will be slightly different, or the designs will be slightly different. So that's what we will be covering today. This week was all SQL. Initially, just very simple select by star lookups, and then you guys went into joins and unions, I believe. Any big question from what was covered this week? Not anything necessarily specific, but just overall, the importance of it, how it's used, what's the purpose of SQL databases or relationship databases. No questions? Do you guys ever tell someone to Xerox something? It's more of an old term, but anyone ever say that?
Yep.
Yeah, hey, can you Xerox this? What's weird about that statement?
You're using the term of a company. It's like Googling something.
Yeah, exactly. Right. So when they say relational database, almost exclusively they mean SQL. It's kind of like that. It's on that level, right? In terms of querying languages, SQL is the go. Undisputed, the Xerox, the Google on that level. Make sense? So anytime someone says relational, you think select star from whatever. Yes? Uh, you see a bunch of let me share my screen. I'm gonna see if I can find it. It's gonna be embarrassing if I can't. But I see this sometimes. Can you guys see my screen?
Yeah.
All
Yep.
right, jump into it. Sometimes you see SQL like running signs. I've seen these at races before. I see if I can pull something up. Running signs funny. Right. See if I can find it. Like none of them are coming to my head right now, but I've seen this a lot. Uh, Maybe SQL programming humor. Love. If we can find something. Oh yeah, you'll see something like this. I've seen running signs. If I used to run a lot, so I do road races, and sometimes you could tell if a family was like full of programmers and stuff because they would have like a little like sign holding up for like the wife or the husband or something or the kids. Or, well, not the kids typically. It's always the husband or the wife or something. And they'll do something like this, like select star from contacts where behavior is nice. SQL clause is coming to town. Like that's a programming humor. You know what I mean? They're using querying language to kind of make a point, but you could, select, husband from contacts where, uh, where love equals me or something like that. You know what I mean? Anyway, I don't know why I'm sharing with that with you, but I just think it's funny. So if you ever see signs like that, that's, oh, this is probably a good one. It's like start from world where someone, like you, right? That's cute. No, am I the only one think that's cool? All right, well, F the world, I guess. Watch it burn. Anyway, back to this. You guys can see my screen, right? All right, so SQL schema design. Let's look at this little table, and there's a lot going on here, right? So we're going to try to step through it a little bit. I kind of hinted towards what we were going to cover today on Monday. So hopefully you didn't forget any of that. So SQL schema design. Let's say your first day on the job, your boss plots down this database in front of you. And notice it's only 2 rows. ID, name, Bob Jones, Sally Smith. There's 2 addresses. There's age, there's birthday, And then there's a couple columns that are a little different. Order item number, order item cost, order total. What could this be?
That could be that could be a store checkout list or something like that. I don't know.
Yeah. Yeah, it appears to have customers that buy stuff
Hmm.
from somewhere,
Right.
right? By
Right.
looking at this, by looking just at this, right? What's the minimum number of data tables this database has probably?
Two.
Yeah, minimum too. Which are they, Cisco?
Uh, you got a customer database, and then you have uh a product database, I guess, or something like that.
Yeah. If I said actually Cisco, I don't know. This is a made up example. So, but let's say hypothetically I said Cisco. There isn't two, there's three. Give them to me.
Uh, yeah, I would say
You got two of them, so split it up one more time.
a huh,
Maybe if you have like products and sales, like the items that you're selling and the actual sales that are made.
Yeah, but that's more or less just an aggregation, right?
mm, hmm
Sorry, Cisco, I tried to help you for once.
yeah. I appreciate it, Joe.
Hey, have you guys ever heard the phrase "no good deed goes unpunished"? That's what just happened.
Well, maybe a shipping table or something like that. I don't know.
Uh, Potentially, but that's not apparent. Potentially, but it's not apparent from just looking at two rows, right?
Mhm.
Right. Maybe there's probably an address table, right? There's a users table, right? That has a foreign key to probably an address. Why
Okay.
you're going to come to realize that addresses are somewhat complicated. Just look at it. Why do you think addresses are somewhat complicated?
Oh yeah. Well, you got because you got states with different cities, and then you got cities with different street addresses. So, you know,
Yeah, you have states with the same city.
mhm.
You have cities with, I think, what is it like a very large, I'm not going to throw out a number because I'm probably going to be wrong, but I think a really large percentage of X cities in America have a main street, right?
Right.
So
And
Main Street's going to be awfully common,
yeah,
or a first street, or a
right.
second street.
Yeah. Yeah.
Anyway, so if you had to just break it up, you're probably going to have users, you're going to have, you know, some kind of a address table, and then probably products or something, right? But this could easily have um, some kind of inventory table too. We don't know that from just looking at this, but that wouldn't be unreasonable, right? Um, and bro, check out this awesome project that I get a chance to work on. And this kind of relates very directly to this, right? Well, I worked on this project for a big movie theater chain, right? And what people don't realize is some movie theaters have servers on location at the movie theaters. What do these servers do? Well, they take a lot of information that they eventually send typically to the cloud or to somewhere where it gets aggregated. But the servers at the movie theaters, right? They're running inventory tables, right? Based on sales. All right. So what happens when, the butter of the popcorn runs low? It sends a purchase request for X amount automatically, no human intervention needed. That's dope, right? So that's how this stuff can be used in the real world, right? I worked on that project, right? You wouldn't know that unless you worked on something like, right? Very cool. Anyway, so there you go. Again, that's made up. but if you had to look at it, you see what, and this kind of thinking is kind of how you're going to ultimately design your own uh, database schemas, right? For your projects, right? Because depending on what kind of project you have, you're going to store different kind of data. You're going to need to retrieve different kind of data. You're going to have to use different kind of not only tables but potentially databases, just like we described, or just the way that we discussed on Monday. Okay, so questions about schemas. What would make this table? How organized? We already talked about that. Questions about data. What would happen? And this is important here. What would happen if Bob Jones moved or Sally Smith changed her name? What if someone, or let's tackle this one at a time because there's a lot going on here. What would happen if Bob Jones moved based on the table above?
You'd have to update the original table, and it would have to, this schema would have to essentially pull the update from that original table.
Okay, what about if you overrid it though? And they get mad because you sent a package to their old address.
Bob's going to be really upset. He's going to send you another.
But what do you have to, as a good company, what do you have to do? You can't overwrite his previous address. You have to do what?
Just
Just think.
update the log, like have another, I guess, not column, but another table to update to show that he moved, or there has to be a log of it somehow. I don't know how to say that
There
properly.
you go. Yeah, you're right. Right. There has to be a history of it. Right.
History, that's the word.
Yeah.
Six
So
invoice.
so that starts getting a little complicated, right? Look at the table. It's only two rows and a couple columns, but all of a sudden, Bob Jones moved. Okay. So we could overwrite it, right? And Bob Jones no longer lives at 123 Main Street, Anytime, Illinois, right? He lives at, 456 Second Street, somewhere, Illinois, right? So that keeps this specific table intact, right? But then we lost his previous address, which might be useful, right? So you're not going to be able just to delete it, right? A good company would find a way, right, to keep a history of any changes to this table, right? And that information has to be stored somewhere. So it's not as straightforward as just overwriting it. Initially, hey, we're going to start with just overwriting it, okay? Uh, but ultimately, right, these things grow in complexity for the exact same reason that I told you, right? You ever go to your Amazon account or you lost your credit card, you have to update it, right? You can add a new card. You can, I don't even know what the limit is, but you can add a bunch of different cards. You know what I mean? It has a history of it, but then you have to specifically go in there and delete them. Make sense? Right. Now, if it's a good trustworthy company and you say, hey, delete this previous card for whatever reason, maybe you just don't want it there anymore, right? A good company should delete it, right? But some companies don't, and they keep your data and they sell it, right? So there you go. All right. What would happen if Bob moved? You had to account for his address, right? And there has to be a history of that change, right? Okay. What about if Sally Smith changed her name? You run into a very similar problem, right? Keep that in mind. What if someone ordered more than one kind of item? Let's deal with this one right here. There's a lot going on here. What if someone ordered more than one kind of item? Here, look at an order item. Right here is this person hasn't ordered anything. This person ordered a lamp. But what if Sally Smith ordered a pair of shoes too? I don't
Yeah.
expect you to, yeah, I don't expect you to have answers here. I just want you to keep that in mind. Just look at it, just think about it, because this is ultimately what you're going to do. What if this application were to scale up to millions of orders per day? Right? Just think about that. And you think, oh, that's unreasonable. No, it isn't. Walmart, Amazon, Tractor Supply, all these big companies probably handle that. Right? Nike. That's not unreasonable at all. Alrighty. A table like this is the kind of thing you might end up with if you didn't spend much time designing the database. But let's look at it objectively for a minute. Pros, it's simple. Everything is in one place. Cons, it won't scale well. Updating data would likely be very dangerous. What does this mean here? In programming speak, updating data will likely be very dangerous. What does this mean?
You might break the app or inadvertently delete something that you might need.
Yeah, that's what they mean by dangerous. Either break something, but really kind of what it was meaning is delete something that you're going to probably need. Right? What about if you were in the middle of updating a credit card number and there's an error in your code and it deletes the old one, but doesn't update the new one properly? What's in that column? What's in that row? Error? Does it break the database? What happens? Just something to keep in mind. Again, just really a thinking exercise. All right, so we can break the issue into one big table approach into two basic categories, repetition and integrity. So this is a conceptual thing. All right, repetition and integrity. Repetition is already familiar to us as a general programming concept. We really only need to store Sally Smith address once. We don't need to make a new copy of that information every time she places an order, right? So that's why we have accounts. Like if you create your Amazon account, typically you create it once. Yes, you can update addresses. Yes, you can ship stuff to different addresses, but typically you don't, right? You can, right? And that's typically a one-off. But typically if I go into my Amazon account, I always think of it because I always order things at Amazon. I hate going to the store. But it has my address, right? And I just add to cart, check out, press another button, and this ships it, right? So we don't really need to store Sally Smith address once. We only need to make a copy of that information every time she places an order, right? Because Sally Smith or Guillermo on Amazon, I can have a lot of different orders with a lot of different items, right? And I can have it all shipped to my house, right? As I often do. All right. We can derive someone's age from their birthday. If so, then we don't need to store their age separately, right? As long as we know their birthday, we can keep a running total. I don't know if running total is the right word, but you know what I mean. You can just subtract current date from their birth year and always have their age down to the day, right? Right. So you wouldn't store age 38, right? You just store their birth year, right? Pull in the library of time, do some quick arithmetic, and you always have a running total of what's in that column, right? Age 37 years and 127 days. You can break it up into months if you want, whatever. Make sense? All righty. Integrity, and this is important, has to do with how reliable your data is when things change. Remember the example that I gave you? Right? What happened if there's an error as you're swapping something out, right? That's what this means. What if Sally Smith types her address in incorrectly one time, leaving you with two different versions of the address? What if she moves? Would you need to update her address in all other records? What if you miss a spot when updating her addresses? Right? This is the integrity of the data, right? Is it correct? Right? And we haven't, I don't think this is going to go into it, but there's a layer, there's repetition, which you understand, right? There's integrity, right? But eventually, as you scale an application, right, as you scale an application, right, you're also going to have, right, consistency, right? What if you're pulling your Nike orders from Chicago, Illinois, but you've heard how great Japan is? And you take a flight on over to Japan and you're pulling that data, right? If that data is being held, right, close to you, close to Chicago, Illinois, but you're pulling now that data from Tokyo, Japan, is it going to the same database? That's a mighty expensive call. That's probably a weird example. Let me give you a more reasonable example you might understand, right? I'm in Chicago, Illinois, right? I'm watching the new season of Squid Games, right? But then I fly to Tokyo, Japan, and I start watching Squid Games. Where's that data being held? Is it close to me in Chicago, Illinois? What if I want to watch it in Tokyo, Japan? It's going to go all the way to Chicago to grab that data for me? How long is that going to take?
They're probably using a CDN.
Yes, right? But conceptually, right, these ideas are important. Just a thinking exercise, right? You're probably going to have multiple databases is the answer, right? Spread across the globe, the whole versions of it, right? And somehow if you update one, they should all eventually update, right? But if you happen to pull information from one database before updates, right, from close to where you are in Tokyo, right, it's very possible someone gets an update in Chicago before you do. Maybe by just a couple seconds, right? This is called consistency, right? Is it eventually consistent or is it always consistent? Right? Eventually means there's a lag, right? If the update goes at the same time, then it's always consistent, right? So these are just two concepts that you understand, but eventually at scale, you're going to have to understand a little bit more than that, something a little bit deeper. Just another example. All right, so let's get back into this. Avoiding repetition helps you maintain data integrity and vice versa. If Sally's address is only ever in one place, then it's much easier to maintain. This is very similar to don't repeat yourself, right? And why your functions, right, should be agnostic, right? And when anything that a function needs, you should typically always pass it in, right? The example that I gave you when we're pinging APIs, why don't you just pass in the URL and the parameters? And the only thing that function needs to do is put it together and make the call, right? It's not hard-coded just to one URL or one parameter, right? It's a simple pass in the URL and passing quarks. Give me 0 to an unlimited number of parameters. Concatenate the API, the string, make the call. Based on how the server responds, parse that data, send it. Make sense? Okay. Very similar. So if Sally's address is only ever in one place, it's much easier to maintain. Very similar to why you never repeat your code, right? So how do you avoid repetition and maintain data integrity? It turns out that's a whole thing. Feel free to read this. I'm not going to get into it. I can open it though. Read on normalization. Give it a shot. It's more depth that you necessarily need right now. So if you want to kind of skip it for now, that's okay. As long as you understand this at kind of a higher level, you're going to be fine. But for practical purposes, and this is the important part, It mostly comes down to extracting entities into separate tables. And when making sure you can connect the tables together, right? So for Postgres, you can create a cars database that can have how many tables?
3.
Any number of tables, really. but yeah, right. It's not a hard number, right? Is a database a table?
Yes.
A database has tables. Now it could be 1, but it could also be 20. Keep that in mind, right? When people say a database, right? A SQL database, your mind should automatically go, it's tables.
Mm.
We're going to query data in tables. That's it. All right, so here we go. What if instead of SQL, you had to take this table and turn it into Python classes? You might start with something like this, right? And we're referencing the table up here, this one right here. That's it. All right, so if we were to turn this database table, this very simple database table, into Python, you'd have something like this: class customer, class order, class item, right? Pretty simple. What kind of attributes would these entities have? You might come up with something like this. For customer, you're going to have ID, name, address, age, birthday, basic, login stuff, or user account stuff, I should say. Order, you're going to have item, quantity, customer. What would this reference? I'm kind of foreshadowing a little bit here. If this was a Python class order, self.customer means what?
It's the part of the customer class, or it's
Yeah, it's whoever did what?
or it made the order.
Yeah, whoever made the order. All right. Item number, description, and obviously cost. Right. All right. So we can break this down further. What about address? Arguably, an address is actually a very complex object, like I was mentioning earlier. You're going to come to realize there's a couple things in programming that are not that easy. Address is one of them. The other one is time. Time kind of sucks to deal with.
Mm.
It just does. It's never that straightforward. There's always something weird going on. There's like 6 different ways to format it. It just sucks. They'll figure it out eventually. So address, complex object. We could pull it out as its own separate entity, right? And that's kind of what I was kind of hinting to earlier. So let's see, why don't we just create an address class? Okay, so we have, because address has a lot in it, right? It has a number, that's an int, right? It has a street, it could be a string. It has a city, it has a state. Your address typically in America also has a what?
Zip code.
Yeah, it has a zip code, which is also an integer, right? Which is useful, very useful. For what specifically? Just distributing packages or finding location. That's it. But it's another marker, right, that lets you pinpoint exactly where something is, right? So here we go. We can keep going and continue extracting entities and making refinements, but this is fine for now. Instead of defining these entities in Python classes, let's see what they look like in SQL. Unlike Python, SQL wants you to tell it what type of data a given column will be. Postgres has a bunch of types to choose from. You can click on that link and look at them, but we're going to keep it really, really simple. And for your personal projects and your group projects, the schemas are going to be pretty straightforward. They're not going to be anything too overly complex. Okay, so just don't get overwhelmed. There's only a couple things here that you need to learn for now, and eventually you'll expand your domain knowledge. So let's look at it. So this is a little bit of the syntax that we saw earlier on Monday, right? Right, so here we go. Create table address. An address has an int, right? You have to tell it in SQL what it is. Number, int. Street is just a varchar, just a string. City, same thing with state, just a varchar. So more or less a string. So create a table, customer, and then the ID has a primal serial key. And this is kind of what we talked about on Monday. It's going to have to point to another table. We'll get to that in a second. So name, varchar, and then address, right? It's a string, but then here we're going to discuss exactly how you get it to point somewhere else, because it's going to be its own table. Then we got order, item varchar, quantity int, customer varchar, and then table item, the item number, the description, and then cost. It's an int, right? So if you were to recreate these Python classes in SQL, they would look most roughly like this. Slight difference in syntax, and you need to tell it what the variable name is, like what data type it is. Okay, so there are 3 fields that I'm not sure about. What is customer address here? This. If you read the sentence, it tells you, right? It's a reference to another table, right? Because address is complicated. It's not just a string, right? There's a lot to it. So we're going to dive into that. It's a reference to another table. So let's look at how you connect tables. Let's focus on the relationship between customer and address. SQL databases are what kind of databases?
Relational.
Relational. What's the other big kind of database? What are the 2 big databases that we discussed on Monday?
Non-relational.
There you go. Relational and non-relational, right? Then you get into cloud, which is just a version of 1 and 2, right? And then you get into specialty, right? But the 2 big ones, the most commonly used, are relational and non-relational. This is a relational database, right? Because tables have relationships to each other. All right, so here we go. This is create table address again. Numbers and int, all these are varchars. Then we create the customer class, right? Has a serial primary key, which we're going to discuss in a second. Has a bunch of varchars and int. Remember I told you that date was somewhat complicated? Birthday is a date right there. And that's just a type of, right? That kind of like a data type. So let's look at address here, right? The customer has an address. So the customer needs to hold a reference to address, right? How many addresses can a customer have? We're just going to say for now, 1. We're just going to say for now 1. But as we discussed earlier, right? In really good databases, they probably keep track of all your past history addresses. Make sense? So there's going to have to be a way to account for that. All right, so we'll keep it simple, say 1, but notice that given address could belong to different customers, such as a husband and wife living in the same house, right? Or if you have a family, then you guys either share an Amazon account or don't share an Amazon account. Guess what? The address for all those are the same, right? It's the same house, it's the same apartment. Presumably you have a happily family and you guys live together, okay? In the database assigned terms, this is called a one-to-many relationship. Such relationship are implementing using foreign keys. So the reference to the address table in customer is expressed like this. So in address, you have an ID, serial primary key, and you have the same thing in customer. But look at address ID here. It is an int, right? Address ID is an int, but it's references with the keyword here, references address ID here. So when you look up customers in the customer table, right? and you look at column and it says address ID, and you pull it up in your little terminal, you know that it's pointing where? Some kind of address table, right? Because notice how it doesn't say address. It says address ID. That kind of tips you off to say, hey, this is an integer that's referencing a separate table. I can go in there and find it, right? But luckily for us, we know SQL and we can just query it, right? Remember when you were doing queries and you were doing joins and all of that, right? All that information is being queried and pulled into one of your views, but you're not creating new tables, right? This is a really important concept. You're not actually creating new tables. You're just querying the data from different tables to show it to you in the terminal. You haven't moved any data. That data's still there. Make sense? Okay, that's a conceptual thing that you have to really understand. All right. So I made a slight change. Address is now address ID to show that it is actually a reference to the row in another table. The data type for a foreign key is determined by the data type of the column being referenced. In this case, address ID is incrementing integer, a serial, and that's just a data type for SQL. So customer address ID needs to be an integer, right? And these things you won't make up, right? These things are pretty much set in stone for SQL, right? If it needs to be an integer, it will be, right? For serial keys. And they have to be unique, obviously. So customer ID obviously needs a reference to address ID, but each address ID needs to be unique. Otherwise, the reference from customer ID would be ambiguous, right? That's what I was saying. It has to be unique. It has to only point to this address. The easiest way to do this is to make address has a unique primary key. We can connect customer address ID to address ID and be sure that there will only be one match. Under the customer table, it has address ID, which is an integer that references address ID, right? And this ID will only point to one address because the ID is unique. Because we don't want it to point to multiple addresses. Again, we're keeping it simple, but in reality, can a person have multiple addresses? You could, yeah. People own real estate. You could have 3 houses. But again, for this one, we're just going to keep it simple. All right. So because we separated customer and address into their own entities, i.e. tables, we've eliminated the need for repetition. Because we connected them together using a foreign key, we can make sure that customers have an address. And when we get the address for a given customer, we can join the tables together, right? Let's go up top and look at this initial database. Let's say we have a family, right? Let's take my family, for example, right? My family has really prototypical Mexican names, so I'm sorry for this. So my dad's name is Juan, my mom's name is Maria, my name is Diego, right? We all live in the same house, right? So imagine those 3 names all having the same address, right? What if we all move? Are we
Then
getting
you,
chess? Go ahead.
I was going to say, then you only have to change it in that one area and it'll update for all 3 people.
Yeah, exactly. So that's the point of it, right? It's very maintainable, right? Pretty much every major city in the world has giant apartment complexes, right? Imagine you had to update a lot of those if people moved. That'd be really not maintainable at all. Cool, 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 cool. So I know this is a lot conceptually, but let's look at the challenge. All right, Craigslist schema. Oh, actually, let's talk about relationships very briefly, and then we can talk about let's talk about relationship first, and then we'll talk about the Craigslist schema. So there's a couple. There's what four relationships you need to know, right? There's a one-to-one relationship. Someone give me an example in everyday life that's a one-to-one relationship. I gave an example on Monday. You can give the same one. Guillermo can only have one what? What's the one thing that Guillermo in this country can only have one of?
Social security number.
There you go. That's a one-to-one. That is a strong one-to-one relationship. I can only have one social security number, right? Four relationships you need to know. That's the first one. You're going to have a one-to-many relationships. Someone give me an example of one-to-many relationships. Guillermo can have lots of what?
Like if you're a fraudster, then you could have a lot of
No. Let's keep it really simple, right? All right. So
You can have multiple credit cards.
there you go. That's a good one. A one-to-many relationship. Guillermo can have many credit cards. Guillermo currently has 2 credit cards, right? But Guillermo knows people that have 10 credit cards, right? One to many. All right. Here's a slightly more complicated one. The next relationship you need to know is a many-to-one relationship. Many-to-one. Someone give me an example of a many-to-one.
How about a shipping address and multiple shipping addresses?
Ooh, be a little bit more specific. That's confusing me.
Well, you're making me appreciate Amazon more and more because, like, when I order something from Amazon, sometimes it might take 10 days to get to my house. But if I select a locker location to be delivered, I can get it in 3 days. So in my Amazon account, I have like 4 or 5 different addresses and I choose depending on how fast I can get there. So I'm one person, but I have multiple shipping locations.
No, that would be a one-to-many relationship, depending on how you phrased it. I'm looking at a many-to-one relationship. So both of those are relationships, they're just different. All right. So we talked about a one-to-one. Guillermo to social security number, one-to-one, right? We talked about one-to-many relationship with Guillermo could have many credit cards, right? But a many-to-one's a little different. What's one thing that can have many relationships? This is really simple. You go to them all the time. What's one
Uh,
thing that can have many of something? What about your
um,
favorite restaurant? Can have many what?
locations.
or menu items.
Yeah, they could also have many reviews and many customers, right?
Mhm.
Right? Many to one. So the key word here is to one, many to one, right? To me, my favorite is reviews or customers, right? Because you can have, um, let's make this really simple. Just keeping your head reviews. A restaurant can have many reviews, right? Because this gets us to our last kind of relationship. It's a many to many, right? And that's kind of like the opposite, right? That a restaurant could have many locations. Many locations could have many customers, right? Or classes. There could be many classes at a university, and many students can take many classes. Make sense? All right. So those are your 4 main relationships in any SQL database: one-to-one, one-to-many, many-to-one, many-to-many. That's it. You can build pretty much any application with those, right? And if you start thinking of really big applications, you can kind of see, right? What's probably the prime example of a many-to-many relationship in today's world? Think online.
Uh, let's say Amazon.
No,
Easy.
not quite.
No, not Amazon shopping.
You would have to give a really specific example because you only
Mm.
have one account, right?
Hmm. Hmm.
Like if you use that as a many to one example, that would work, right? Because many people have one Amazon account.
Hmm.
Social media,
Uh,
so many to many, right?
hmm.
I can have a bunch of friends. I can have a bunch of posts. Who can have a bunch of friends. I can have a bunch of posts. That's the quintessential example, right?
Mm.
Alrighty. Let's look at, sorry, I know I've gone a little long. So let's look at design Craigslist and then we can take a break and then I can cut you loose here for the first part of this. So this is a Craigslist schema exercise. Just clone this. I think I already have actually. Yeah, you clone it, you're going to get an empty Docker file. You're going to get the steps, create a database, connect to the database, create tables, insert data. And here's your README. You're going to design a schema for Craigslist. Keep it as simple as possible. If you want to go all in, do that as a second pass or a third pass or a fourth pass. This is actually a really important concept for programming, guys. When you go about building a solution, you're not going to build it in one shot, right? You're going to have to do it piecemeal. Build the first part, right? Test it, build the second part, test it, right? Parse it out, right? So I would start with the simplest Craigslist tables, maybe start with 2 tables, right? And then do 3, and then build it out that way. Because if you try to build it all at the same time, it's not going to work, right? At least a lot of the time it doesn't. All right, so keep it as simple as possible. This really should say, if you want to do it all out, do it on the third or fourth pass. You'll probably want to have user, add, and category tables, right? Initially, I would actually just start with user and add. Why am I telling you this? Why start with user and add? It's simpler and it's what kind of relationship?
One to one or one to many
Yeah, because a user can have many what?
ads.
Yes. You start involving categories, that starts getting complicated, right? Initially, it's pretty straightforward. One to many relationship user add. But you start getting categories. There could be a lot of user can have ads in multiple different categories, right?
Mhm.
But you can also have a bunch of users that have a bunch of ads in different categories.
Mhm.
It can get unwieldy pretty quickly. Just start with user and add for now, right? If you figure that out, add category. Once you have the schema designed and visualized, perhaps using a tool like Quick Databases diagram, you'll implement it following the model of the CARS database. And the CARS database is what we use, this right here, what we used last time. And it's in the repo, right? The tool will give you something like this, right?
Mhm.
What was I doing? Oh yeah. So if you don't want to make up the data yourself, you could try this and I'll mock it up for you. My piece of advice is insert the data manually. Drop the table, recreate the table, get really comfortable with those commands so they become kind of second nature because you're going to be doing it a lot for your personal project and group project. So I would insert the data yourself because you really only need to insert how much data to get started here. Just like 2 or 3
Just
rows.
two. Yeah.
Yeah, just 2. That's it. You can do it manually. But once you get the hang of it, feel free to use these resources. When you have your Postgres container running in your database, write a few queries against it to make sure everything is working, right? So that's the overall project for today. Questions?
Nope.
How many tables does the database have?
Many.
It can have many. Can it have one?
Yeah, we can have
Is
one.
that going to be a good database? Probably.
No.
Probably not. Going to be pretty crappy. Unless you're holding the most rudimentary of information, in which case you would have to question why you even need a database in the first place. Alrighty. I know that was kind of a long lecture. What's going to happen now? It's 8:52. Definitely take like a 20-minute break, grab something to eat, relax for a minute, and then come back and get started. I'm going to open all the breakout rooms, jump into them, start working, and I'll jump around. Give you guys a little bit of time with this to struggle with it, and then we'll probably meet back up maybe a little before 10 to kind of see where you're at and continue. That work?
Yeah.
All right. Go forth. Break. Start. How do we do? Where are we? I should say. I don't expect you to be finished, obviously.
I got the database made, but that was about it.
Yeah. Okay, that's good. That's a start. I'm gonna go out on a limb and say maybe some people didn't even get that far. We got the
Yeah.
database made. Yes?
Yeah. Well, I'm still creating the schema.
Okay. Excellent. Adam, can you walk us through how you created that? Because that's actually what I was going to go over.
All right, so let me pull it up here. Oh, just to let you know, I'm on my phone right now because my new Mac Mini does not have enough USB ports for my camera or mic. It's a little
No
awkward.
worries. If as long as you can share your screen. Wait, you
Oh,
can share your screen, right?
no, I can't.
Okay. No worries. No worries. I'll walk through it. Give me one
Okay.
second. Let me load this up.
It probably been one awkward for me just try to explain it.
No worries. Let me try this. All right, this is where we're at, right? This is exactly the repo that you cloned. It looks exactly like this. I haven't done anything, right?
Yeah.
All right, so we turn our attention to the assignment and it's this design Craigslist, right? So I just cloned it, went in here, get clone. All right, cool. It says you're going to design a schema for Craigslist. Feel free to follow along if you can. Keep it as simple as possible. We want to do go all in, talk about doing third or fourth passes. That's fine. Once you have the schema designed and visualized, perhaps using a tool like this will help you. We can follow the model of the cars database. I have it loaded here just in case we need something from it. Okay, so when you have a Postgres container running your database, write a few queries against it. Okay, so how would you start this assignment?
My first thought is just to start creating the schema for it.
Yeah, you could go that way. Or you can do what? Did everyone just jump to straight creating the schema? Kind of hard to believe, but it's possible. You guys just jump to writing the schema? No, you didn't. Maybe one of you did. No one tried to create the database? Okay. Let's create the database very quickly. You can jump to this schema later. How do you start this assignment?
I would just create DB and give it a name.
Walk me through it. This is the
Oh.
point of this lesson right now.
Oh,
This is exactly the point right here. All right, walk me through it. What do I do?
I just wrote create DB space and I called it CList. But I think that DB has to be adjoined to the create DB. There can't be any space like create DB space list. Oh no. Create DB space list. No. Mm. Like create and DB are like all joined. There's no space. Create DB. Uh, uh, DB space list. Yeah,
My DB is named list.
not C list. I just put C list.
Craig's list. That right?
Okay. Yeah.
It's not working.
Yeah.
Why not?
That's the create DB is the wrong command. You got to use create database.
You guys are
Space between data create and database.
all right. I'm gonna stop it right there. You guys are struggling mightily. What's wrong right now? I'm telling you, hey, let's start this assignment. You're shouting a bunch of commands, but they're not gonna work here. What's wrong?
Well, so what I would do is do an SQL file. I'll write it in an SQL file. And then I run the SQL file to actually have it do it. I guess that's
Walk me through it.
Yeah. So under that first instruction, create the database, I would just write in create and space database C list. C underscore list. And yeah, you gotta end it there with the semicolon. Yeah. And then next you do connect Craigslist.
With that,
Yeah.
now what?
Now you have to, and in the Docker file, see here, in the Docker file, you do from Postgres.
Just take it from here, right?
Yeah, you can do that.
This is the car's database. This work?
Yeah, but let's see, Docker entry point. Yeah, that'll work.
Okay. Now what?
Now you have to you can run that. You can create a Docker. Let's see. You have to run the Docker init. Let's see.
Feel free to anybody jump in. It's not just Cisco. What's my next step? All right. So it looks like I populated a Docker file with from Postgres 15, right? I gave it a init SQL command, which is looks like this init is going to be the starting point of my Docker container. Okay. I have these two commands. Now what?
Now you can do the Docker space build.
Docker space build.
There you go. There it is right there. You
Craigslist.
You can hit tab.
I don't have Craigslist DB. I have Craigslist. But I
yeah,
could
you
do
got Craigslist.
DB. That makes more sense. Craigslist database, and I'll make this Craigslist database like that.
Yeah,
Okay. I hit enter.
yeah.
Cool. Now what?
Now you got to do the Docker run
Docker run
dash
name.
name,
I can call it runner. Runner.
dash RM,
Yep. And then my database is called what?
Craigslist DB.
Craigslist DB. Yeah,
Mhm.
like this.
Yeah,
What is this going to do?
that's going to create the database for you. And startup, well, it's going to create a container or image. I can't
Yeah,
recall.
it's going to create it inside the container, right?
Yeah.
All right. Done. This is the ID. Now what?
Now you can do Docker space PS.
What does this do?
It shows the images that I'm sorry, the containers that you have.
Yes. Good.
Okay. Nothing's running.
Nothing's running.
Why is it not running? Huh. Why is it not running?
Let's look at our cars DB. This is cars DB. This is the example they give you. All right. So we go to the Docker file. They give us this command. We have that. Cool. We can check it. Docker file. Yep. Got that. All righty. Cool. Let's look in here. It says build the cars DB. We built it. We built the Craigslist DB, right?
Mm-hmm.
We did the runner command. We did Docker PS, but it's not running, right? So what could be wrong? What could be wrong here?
Let's see.
It looks like we do have an image, but now all of a sudden it's not running the Docker container.
Yeah.
All right, so how do we troubleshoot this?
Can we do Docker images to see what's in there?
Docker images? Sure, is that a command?
Yeah.
Oh, there we go. That is an image.
Mm-hmm. Craigslist DB. Can you pull up the Docker run command? Can you arrow up and
Sure.
see what
Oh, yeah.
we initially ran in there?
Docker run name runner, postcard password, D Craigslist DB.
Hmm. I do not know.
Do I actually need this for now? No, it's not working.
Mm-mm.
This is exactly what I'm trying to show you guys. I'm not convinced you actually know how to start it. So I'm asking you to walk through this. If you can't walk through it with me, that means you don't know how to do it. That's a problem. And we're doing this together, right? So okay, so let's just start again, right? Docker PS, we see that no containers running. Awesome. Docker, this looks right. This is exactly like the example they gave us, right? If I look at this, I have that. Okay, cool. It's going to start there. Awesome. I can create a database that has no tables in it. That's fine. I can do that. So let's just make sure that we have that right. And then we can just add to it, right? So we can build, right? This image. This is, right? This is the exact command that we ran earlier, but we're not going to build CarsDB. We're going to build Craigslist. I can never spell it. Craigslist DB, right? That's the command?
Yeah.
Okay. Okay. So if I check, how would I check the image?
Docker images or I guess PS-A, Docker PS-A.
Okay. So what do you notice here?
Four minutes ago, 18 seconds ago.
The one you created initially wasn't the repository is listed as none. There's an image, but it's not anywhere.
What happened there?
Uh,
The only thing I can assume is this syntax was wrong,
let's
right?
see.
Because I try to.
You didn't have Craigslist underscore DB under the connect on line
Oh, yeah.
5.
I didn't even catch that. Joe caught that,
I didn't
right?
either.
But here's the thing. What I want to point your attention to is when we redid this, and the minute that I saw this, I knew there was a typo somewhere.
Mhm.
I didn't have to see this to know what was wrong. Because this tells me that the image failed to build properly. Right?
Okay.
Okay. Now, if I do Docker PS, it's going to be up. Nope. What am I missing? I haven't done what?
You haven't ran it.
I haven't ran it. And I can go up arrow because I have that exact same command here. Okay. Docker PS. Is it running? Is it running?
Yes, it is.
It is running. Let me make that a little jumbo sized here. Okay, cool. Now what? I want to get it. I want to get in there and start messing around. How do I do it? Docker PS. That container. I need to do what now? I need to get into that container. How do I do it?
You can do PSQL.
No, that's not it.
Oh,
That's not it. Why?
I'm sorry. I'm sorry. You can do Docker exec.
What was the problem there, Cisco?
We haven't started it up yet.
No, it started up. Docker's running.
We haven't executed it. What I'm trying to do is actually execute it through Bash. So
I don't know what that means. That's you're trying to get where?
into
There you go.
the
Keyword there. You're trying to get inside the container. Okay, this is really important here, guys. Right? You see my terminal here? This is an environment, right? That is ephemeral. This inside this terminal right here is different than if I go into the container. Those are two completely different environments. Does that make sense?
yes.
This is one shell. But once I go into the Docker container, that's a different shell. And once I'm inside the Docker container and I go into Postgres, that's a what? Stay with me. This is an environment. When I go into that Docker container, that's a different environment. What happens when I go into Postgres, into the server? That's a what?
Isn't that a database?
Yeah, but what is it? It's a different.
It's a different environment.
Yeah. What are the two tenets of Linux? I taught you this. You need to know who you are and what's the other one?
Where you are.
Where you are. You don't know where you are. That will get you in a lot of trouble in this field. You need to know who you are and where you are at all times. It's going to save you a lot of heartache, right? So earlier, you're shouting commands. It tells me you don't know where you are. Big problem. Okay. I am in my folder Craigslist schema, right? But I know that now that I've created my container and it's running the image that I want it to run, I need to now exec into, did I call it Craigslist runner or just runner? I think I just called it runner. Runner, right? Hey, exec into this container runner and open a bash shell. There you go. You see that? I'm root. I am user root inside this container, right? And it's a bash shell. Knowing it's a bash shell,
Mhm.
I know the echo command because it's a bash command. So I know what it's going to do. I know where I am and I know what it is, right? Okay. But this is just the bash shell of and notice the clear command. It works. Of course it does. It's a bash shell, right? Now what's next? I want to check what tables are in my database. Now what do I do?
You can do
\B.
I can do what? Backslash B or D?
D. D is in dog.
That doesn't work. Why doesn't it work, Adam?
I thought it would. Are we not inside the table
You're
right now?
missing what? Help them out, Cisco.
DT.
What?
Oh, well, did you already do the PSQL into it? I didn't catch that.
No,
Okay.
look at my terminal.
Yeah, okay. So you
It's a
gotta,
bash cell. I need to connect to my server with a completely different environment.
yeah,
What is the command here?
you gotta go into the Postgres
PSQL what?
-H
Dash H
localhost,
localhost.
whatever -P and whatever port you want to connect it to.
What's the default port? 53, what is it? 50,
5330, 5432.
5432.
Mhm.
This is going to connect me to what?
Port 5432 of the local host.
Is this correct? Is my syntax right?
Yeah, that's right.
When I run this command, what do I expect to see in the terminal?
But you expect to see localhost 5432 is it's failed, does not exist. Okay, you want to do a -U after that.
Okay, so what am I trying to do here?
You're trying to log in as the root user, and it's saying root user does not exist. So you got to designate a user that you want to use to log into PSQL or the local host.
Okay, so the command is
You got to do -U and Postgres, and then the -D for database, and then Craigslist DB.
no.
Hmm.
What's the issue here? You're trying to log in with the role Postgres, right, to a database that doesn't exist, right?
Yeah.
So where do we take it from here? Use your resources. What's the next step? How do I log in? What am I trying? How about this? Keep it simple. What am I trying to do from here?
Oh,
I'm trying to do what? I'm trying to connect to what?
the database.
So it's a simple PSQL.
Mm-hmm.
My user is Postgres.
Mm-hmm.
But I don't have a database.
Are you trying to log into the table? Is that what you're trying to do?
Well, there's no tables. I haven't created any. Right? And I can't seem to log in to Craigslist because it doesn't what?
Doesn't exist.
It doesn't exist. Right? So what do I do? What's the only thing I need to do then? I need to just do what?
Create it. Hmm.
So I am inside where right now? says it right here, right?
Mhm.
So I should do what then? Is there a table called Postgres? Is that a default table that always exists? Yes, it always
Mm,
exists on your machine. I need to connect to the database now. So
okay.
I'm in the database now, but I can do Control D. What is this going to do?
It's going to show the databases.
Not the databases, because I'm
The ta-
already in the database.
Oh, the tables. I'm sorry.
There you go. And it says no relations. There are absolutely no tables here. But it'd be dope. It'd be dope if I have some kind of database called Craigslist DB. How do I do that?
Now you can do the create database Craigslist DB
Will that
inside.
work?
Should.
Create database.
Oh, space database.
Create database Craigslist.
Mm-hmm. DB.
This will work.
I'm thinking it will.
What is this telling me here?
It's saying create database is not, I guess create database is not a command.
No, that's not what it says. Read this. This says create database. It looks like it worked. And then I try to check what tables are in. What database am I in right now?
You're in the Postgres database.
All right. How do I get out of it?
You can do command, well, I'm on the Mac, so Control C.
Control C, that's going to work? Didn't work.
Try Control D
Slash
then.
Q.
Is it backslash Q?
I believe so.
Backslash Q. Okay. Sweet. I'm back in my bash terminal inside my Docker container. Now, it'd be dope if I was able to log on to which database?
Craigslist database.
That's a simple typo, right?
Yeah.
Oh, look at that. It exists. Right now, if I do Control D, there's no relations. No relations is telling me that the Craigslist database has no what?
Tables.
Tables. Be super dope. I could create a table here. How do I do it? How do I create a table here?
You can do let's see. You can do create table, create space table, and for instance, users. We can do users, right?
Is that the command?
Yeah.
Create table, users.
Yeah, and
That's it, like this.
Well, you need more. Well, you want to put more stuff in. I don't
No,
know
no,
if
no,
you can
just
create
stuff, just this one.
Okay, that's fine then. Yeah.
This works.
Yeah.
Yes.
Yeah.
Is that a typo at the end? Oh no. Why is my clear not working?
Because you're in a
It only
different.
works in the back terminal.
Yeah.
There you go. I think this won't work. There you go. All right, syntax is different. It's a different shell. It's a different environment. Some commands won't work. Right. I could Why didn't that work?
Because you're not in Bash, you're in a different environment.
Yeah, it's not gonna work. That's the reason why clears don't work. It's not a bash shell, right? So the syntax is different. All right. So just showed you how to create a database, right? Now, what's the only thing you need to start doing now?
Creating the tables.
Yeah. So you created a database. You've connected to the database, right? Those are the initial steps. Create a database, connect to a database. You're on step 3 and 4. Create tables, insert data. That's where you are, right? Questions? You're on step 3 and 4. I'm going to leave that to you for the next little bit, and then we'll come back and we'll discuss where you are there. Make sense? Give me 1 second. I think I missed a chat. Oh, it wasn't a chat at all. It was just a. Okay. All righty. Any questions about where you're going to take it from here? Actually, let's talk next steps before I cut you loose. What's the next step from where we left off? I kind of already said it, but just making sure that you understand it.
Create tables.
Yeah, you can create tables, right? You can create tables manually, right? Or you can start creating your schema inside of that init file, right? And you can delete the image. And this is my suggestion to you. Just delete the image, delete the container, and redo it, right? Practice doing that, right? It didn't seem like we had a strong enough grasp on what needed to happen there. So just redo it, right? It'll give you a lot of practice with just entering the different environments and running commands and knowing where you are. Super, super important. Make sense?
Yep.
All righty. I'm going to open up the rooms.
Because I'm thinking that maybe I just didn't have all of the things I needed in that init SQL for it to do it.
Gotcha. Good. I know that's probably still a little confusing, so we're going to go over a little bit of what we covered earlier, Nicole, to kind of go over a little bit because I think that's where some of the confusion is coming. This idea of environments and what's happening where is a huge issue at the moment. All right, so we're just going to go over it a little bit. Then I'm going to cut you loose for lunch and for you to continue working with this. But I just wanted to cover. I really just wanted to pick up where we left off, and there's a specific reason why I'm doing it this way. Because you're going to come to realize that populating your Postgres database through the init file is much easier than populating the init by hand, right? Via the CLI command per command, right? It's really tough to do that. But it just kind of teaches you that you can do it both ways. And depending on what you're trying to do, right? Different technique is needed. All right, can you guys see my screen? All right, so this is literally where we left off before I cut you loose. So I created a database, right? And now, wait, I did a step 1, created a database. Step 2, connect to the database. So let's do that. Let's connect back to the database because right now I am where?
You're in Bash right now?
Yeah, I'm in Bash where specifically?
Root of the container.
Yeah. I am user root inside of my Docker container. I want to connect to my server, right? So my Postgres server. So this is a simple what?
PSQL.
PSQL. I actually might have it in here. PSQLU, Postgres, right? I'm going to log into a default database that I know it's in there, right? All right, here, right? I can switch to the database it's already created, right? It's a C, I think C stands for change, maybe. I don't even know. Change, and my database is called what? Craigslist DB.
Mhm.
All right, so it's saying it doesn't exist. How do I check what databases exist? I'm connected to my Postgres server. How do I check what databases exist here?
/D
Is it?
DT.
Listen very carefully to what I'm asking. How do I check what databases exist on this server? Huh?
/L
L. DT would check what?
tables.
Database tables.
A database is not a table. Databases have tables, but that's a slightly different relationship, right? It's not a not necessarily a one-to-one relationship though. Okay. It's saying that I do have a what?
Craigslist database.
All right. So how do I switch to it?
/C Craigslist DB.
First line, C Craigslist DB. All right. Like clear, it's not working. That's because
You're not in bash.
yeah. All right. So now I'm in Craigslist DB. The very next step is create tables. How do I create tables via the CLI? Let's just create it with a first name and an email.
Create table,
Create table,
and then
call it users.
parentheses.
First name. Let's just make it really simple. First name and email. Right? Colon. What am I missing here? I need to define what?
The data types.
Yeah, let's just do varchar, something simple. Let's do 20. And then the email is slightly longer. Let's do varchar 50. All right. I'm going to create a table called users that's just going to have a first name and an email. That should work, right? How do I check if that command worked? How do I check if that command worked?
Would you use select on the table?
You could, but there's a better way. I can list, this is the database. I could just check what? What did I do? Yeah, backslash. Yeah, because I just created a table. There should be a table in there. Okay, no relations. That tells me that's probably what? Look at the first command. It's just a typo, right? I forgot it looks like I forgot a what? Looks like I forgot a parentheses, right? Is that right? That looks right. So I can check /DT again. No relations. What's happening here?
You're not in the right spot because it's got that parenthesis.
Yeah, something weird is happening, right? How do I get out and get back in? Like that. Let's try to log into Craigslist DB again. Nope. What about if I log into Postgres? Can I just switch back into Craigslist, right? Craigslist DB. All right, that's working. Let's try that command again. Create table from users, first name, varchar, second email, right? Let's try it again. What happened?
Looks like it went through.
Yeah. Okay, notice I'm not giving you the most optimal commands here. Why am I not giving you the the most optimal commands how to do this? I don't know them. I don't. I'm not a data engineer. I don't really mess with SQL all that much. Don't remember them. I could pull them up, but I'm not going to. Right? If you want to pull them up, knock yourself out. Well, what do I understand that allows me to navigate through this? What do I understand?
The concepts of Postgres.
Yeah, I understand the concepts of Postgres and I understand where I am. Some of the commands I don't understand, but I knew that if I got out of that shell and got back in, it would reset whatever mistake I made. Right? And that right here should have been a clue that, hey, there's a typo right there. What is that? DB? I don't know what that is. Honestly, don't know what that is. But that tells me that something probably didn't go right. And I know it didn't go right because I should have got this. How do you fix this? Is there a command to fix this? Yes. What is it? No idea. Right, but I knew where I was, so I just came back out and came back in. Now, would a real data engineer look at me fumbling around through this terminal and be impressed? No, he'd be disappointed. But that's okay. Conceptually, I understand where we're at, and that's where you need to be. I don't expect you to know all the commands or even remember all of them. But if conceptually you understand what you're doing, you should be able to figure it out without too much trouble. Right? All right. So I know that created. So I know that when I go to DT here, right? Boom. Look at that. What do I have?
The table.
How many users are in there?
0.
Select star from users. What if what's an aggregate function? Is it sum or count? I don't even remember.
Count.
Count. If I do count star from users, I'm going to get exactly what?
Maybe 1.
I'll say that again. What's going to be the count here?
Oh, well, all of the users, but
What are they?
You didn't put in any values though, so it should be
you
0.
didn't, you didn't make any.
Hey, I'm asking you guys a question. I know it's 0. There's nothing in there, right? And there's nothing in there because I haven't done what?
Created
All
or
right. So
inserted it.
let's insert some. Insert into users. I'm going to insert first name, and email. And they're going to be first name and email. And this is just syntax, values, Bob with a little b for whatever reason. And then email, super email at email.com. So I'm going to insert into this users table first name and email. Make sure that my columns are right. Values Bob and super email at email.com. I hit enter. If I did it right, what's supposed to happen?
It'll insert one record with Bob, super email.
Okay, let's see. Threw an error, so that's not right. What is it complaining about?
Super email does not exist.
It needs to be in quotes
Why is that?
because it's a string.
Also known as what in SQL?
Bar chart.
Bar chart. Yes. All right, let's try that again. What do you see here?
Insert 0, 1.
It looks like it was successful. How do I check?
And looking at the table. We're displaying it.
I can just run a count and it's 1, and then I can. It's in there. How do I get it? I want to display all of it.
Yeah, just take away the count.
Yeah, just take away the aggregate function, right? And this is going to give me exactly how many rows?
1.
And it's going to be who?
Bob.
At superemail.com. Imagine if I had to do this 10 million times, right? It would be a pain in the ass. right? So you don't do it this way, right? But I need everyone here to practice this, practice deleting it too, practice inserting one more person. And if I had to insert another person, just backtick, right? Instead of Bob, right, is Alice, right? Instead of super emo is fake emo, right? So now I have 2 users. It inserted successfully. Give me the count of it. I have 2. Give me all of it. I had 2 rows. Now I can start building from here, right? I need everyone to practice this doing manually. Now, you're never going to do this, but it's important to understand what about this, the entire process, right? Back in the day, you have to understand that back in the day, we didn't have really sweet init SQL files where you could just preload all the data, right? You had to do things manually or with API pings or however you wanted to do it, right? And then people started to come up with really amazing things, right? Like pre-populating data and running it inside Docker containers, all that. You haven't even got to the really cool stuff like Kubernetes or K, it's how they call them, or the serverless stuff. That's pretty dope too. But initially, it was just like this. Practice that's going to teach you a lot, right? Once you have this down, right? I have this stuff, right? But I could have easily done what else to do this. So now let's go through the process of just breaking all of this down, right? So I am right now, where am I?
You're inside Postgres,
Yeah, I'm inside Postgres and I am inside which database?
Craigslist database.
Craigslist database. Is this, all right. All right. I want to exit the Craigslist database and I want to go back to my Docker container. It's a simple what?
Command.
What is it?
/Q.
/Q. All right, I'm back at root. Cool. Cool. Right. Is there any way that I can, let's go back even further. Right. I know exit was going to work there because it's a bash shell. Right. I'm going to do Docker PS and see if anything's running. Alrighty, that's running. How do I delete that? I want to stop it from running.
You do Docker stop and the container ID.
Docker stop and then the container ID, this one?
Yeah.
Boom. I can do Docker PS. Okay, nothing is running there. Awesome. All right, so if I wanted to create exactly what I just created, but instead of doing it manually, right, that's what this init file is for, right? How would I do it?
You're gonna you're gonna create the database, connect to the database, create the tables, and insert the data.
All right. So uncomment this.
Yeah.
All right, so I'm going to call it Craigslist init DB,
Okay.
right? And then connect to Craigslist init DB. That works, right? So
Yeah.
just so it's different. Okay. But I want to create my user table too.
Mm-hmm.
So here, I'm going to do exactly what I just did, but instead of doing it manually, I want to do it with my init file because that's going to be way faster, right? So here, I want to do what?
Create
Table of what?
users.
Users. And it's just going to be a simple first name, right? Let's do varchar 30, whatever. Email, varchar, I don't know, 100, whatever. All right, cool. So I created that. All right, so if I did this right, it should populate a table with these columns, right? What if I wanted to insert my 2 people, right? You can even go back to this and see how they did it. They had, so this is how this works, right? And this is how they insert app users. And it's a million of them. Whatever. Let's just steal this. Steal these two people. Okay. So here we're going to do a simple insert app user values, right? I replace app user with what?
User.
Users, right? Users, values, and I'm gonna insert what?
It just should have first name, last name.
All right, so I'm gonna insert
Okay.
into
First one, down like
users,
that.
yeah, values, and then it's just going to have this, right? Values. It's pretty much exactly what I ran into, what I ran in the terminal. Let's call him James, but I don't have a last name, right? I don't have that column. So let's just give him that email, right? That's one. And then what else? Well, we could start literally with just one. I'm going to insert this guy. Is that right?
You need to get rid of, all of that.
Is that right?
Yeah.
Throw a semicolon after the create table users, I think. Otherwise, you might get an error.
Create table
Uh,
user.
Yeah,
Oh,
after
here. Yep. There you go. Good catch. All right. That work? So this should insert this user.
Yeah.
Let's just do it with one user. We're good? All right. Walk me through loading this new Docker container with a new image with this data already preloaded. What do I have to do? I look at Docker PS, there's nothing running. What do I have to do first?
Build it.
Yeah.
Yep. Docker build,
Mhm.
and I'm building what exactly?
Craigslist and it DB.
Craigslist init DB. Yes?
Yeah.
This is just building the image that my Docker container is going to use to run off of. All right, so I'm going to build it. That looked like it worked. Cool. Now what I want to do?
Now you want to run Docker run name runner Postgres password -d Postgres.
This?
That did not work for me. So I actually used the Postgres default database to get it to actually run the container. That's
Okay, let's try this.
You can try that.
Yeah,
Let's try this.
I want to see what happens here because this is what was giving me an error, and then it was automatically stopping,
Right.
and removing because we had the RM flag in there.
Yep.
Right.
All right, so this looks like it created it, right?
Mhm.
So how do we check?
Docker PS.
And what do we expect to see here?
Expect to see a list of containers that's actually running
Okay,
or available.
and it's not.
Yeah.
Same thing, man.
All right, so what's the issue here?
I think it has something to do with the Craigslist in it DB. It's not finding it. Something I don't know.
This is what Nicole, I think, figured out. Can we run the run command again, but get rid of the RM flag, and that way we can check the logs here. Yeah, PS-A shouldn't even show anything either because the RM flag is automatically like getting rid of, that might not be the right words for this. But the RM flag would preclude it from showing in the PS-A. So if we run it here, we can run logs and then see what the hell the issue is. And that's where I stopped before.
Okay, so same issue. So Docker logs.
Docker logs runner, or maybe it might be Docker log runner. I can't remember which one it is. Yeah, there we go.
All right, let's look.
Syntax error near correct.
Which line?
Oh, okay. There needs to be a slash, backslash. I'm sorry. Yeah.
Oh, in line 5, there has to be a slash before connect, right?
Yeah. But I still put that in and it still didn't work.
Yeah, me too. Damn
This?
it. What the hell?
Yeah.
This?
Yeah, that. Yeah.
All right. So what do we do now?
You can try to run it again and see what the logs say.
This?
Yeah.
What's the issue?
The container name runner is already being used by another
Yeah. So in
container.
reality, you should destroy the container, right? That has the same name runner, or you could
You could change the name.
runner two. That fixes it.
Yeah.
Docker PS. No.
Still not running. Yeah.
Docker logs.
Yeah.
Yep.
Runner two.
Jeez Louise. It's still complaining about connect. Why? Are we accepting database systems ready to accept connection?
Is it
System-
connect or is it /C for this? Because I've seen it, I saw it both and it worked. I can't remember which one it worked for though. I don't think that would be the issue, right?
Let's try it. You want this?
Yeah, I guess.
Well, what do you have to go off of?
Yeah, it should be. Yeah, it should be that.
This
Maybe. Is it the semicolon? I don't know.
in create init DB.
Yeah.
That's a semicolon right there.
Well,
No, and the
not
connect.
in the connect part. Is that what's hanging up? See, you got it at the end of Craigslist DB right there.
Oh, there you go.
Yeah.
And change it back to connect. Yeah, yeah.
Yeah.
This is so annoying.
Yeah, it
Alrighty.
is.
Let's try it.
It is annoying, isn't it?
Let's try it. All right. So now what do I want to do?
Runner 3.
Yeah. Might as well.
Runner three?
Yeah.
You can just destroy the containers when you do.
Yeah.
Guys,
I-
there's a command that will just delete the image and delete the container and delete everything. Figure out. I can't
Right?
remember what it is at the top of my head, but just do
Maybe
that.
purge. Yeah.
It's Docker prune or purge. I can't remember.
There you go. I should know that. I haven't worked on a Docker thing in like 8 months, so I don't remember. But yeah, Docker prune and purge everything. All right. So now it looks like it created it. Docker PS. What do I expect to see here?
The
The
container.
container ID.
Nope.
Son of a.
Docker logs runner 3. All right. What's the issue here?
Connect. Syntax error at or near connect. Well, it's still showing. Wait a minute. Why is it still showing the semicolon in there for the line?
Did you save it?
Did you save it? Yeah, I mean,
Yeah. Let's say it. Let's say it.
yeah, but it's showing a totally different. That's not the correct line though. It says line 1, Craigslist. Where is it? Is it pulling it from the right file?
It is. It's a NetDB, right?
Mm-hmm.
Hold on, let's see. Yeah. I don't know. Craigslist schema. Yeah, but that's hmm. Let's see here.
Does it have to be lowercase or does it matter?
It shouldn't matter. I don't
It
think.
shouldn't matter. All right, let's try it. So now what do we do?
Container or runner 4. Or you can prune, I guess.
What are you guys missing here? You edited this init file,
Mhm.
right? So you need to do what?
Oh, I'm sorry. Yeah, you got to do the build again.
Oh, yeah.
Why is that?
Because it's just a new you're
Image.
yes,
You need to build a new image, guys. Anytime you edit this, right, that's a new image. It only launches on initialization of the container,
Yeah, that's right.
right? So let's do that again. So it's Docker build
Hmm.
this.
Yeah,
Mhm.
Docker build T. Yeah.
Built it. All right, this should work. All right, so we built it already, so now we have to do what?
You got to run it again.
All
Yeah.
right, we're gonna run it with runner 4. Docker PS. There it is.
Hey, I rebuilt my image every time I did this and it was still screwing up. So I don't know what the hell.
It might have been a semicolon after line 5.
Yeah, maybe I gotta
All
connect.
right, so now I want to check in there and check if, hey, did my information get loaded properly? What do I want to do? Docker what? So it's running. I checked Docker PS. It's running. Perfect. I need to go in there and check if my data's in there. What do I do?
PSQL.
Not yet. I need to go in where first? Look at my terminal.
Oh, you need to go into that database.
I need to go in there where first, though? You're jumping the gun.
Root.
Yeah, but I need to jump into.
I don't know.
I need to go into the container. So I need to do what?
You need to run the exec,
Yep. I need to exec into
the container
runner
ID.
4. 'Cause that's the container.
That's what I was trying to say.
There you
Yes.
go. So this is just a bash shell, so I can clear all I want. And then I can log into, I know that I already, this Docker container is built with a database called Craigslist initdb. So I know that I can just simply PSQL into what?
The Craigslist DB.
All right, so how do I do that?
You shall. Let's see. You want to run PSQL-H localhost.
PSQL-H localhost.
Yep. 5432.
5432.
And -u.
-u, that's right. -u, Postgres.
Yep. -d.
-d. Database name is Craigslist initdb. Is this right?
Yeah.
Look at that. From what table?
Users.
Yeah. So I showed you how you do it manually. Practice that. And I showed you need to rebuild the image anytime you edit the init. But I could have done this a bunch of more times. So speed run, and then I promise I'll let you go to lunch. Speed run. I just inserted another user. What needs to happen here?
You need to rebuild it.
Okay, so walk me from where I am.
/q. Exit. Rebuild or Docker build. Yep. Now run it. You can call this runner 5 if you want, or you can just prune all the stuff.
I need to figure out that prune command too. I'm not gonna keep doing this, but runner 5. So I built a new image. Now I'm running a container off the new image that I just edited. Cool. Docker PS. Notice 2 containers running. Now what?
Do you want to stop the old one or just let it go?
Nah, let it rip. Keep going.
Yeah, that's the latest one at the top.
Now what?
You want to
Docker exec into what?
Runner 5, or is it 4? 5, yeah.
Now what?
Now PSQL.
Yeah.
What was the next line?
Pull it up.
Was it localhost?
Localhost, yeah. Dash T
Localhost port 5432,
32. Yeah.
right?
That, yeah.
You
Dash U.
username Postgres.
Yeah.
Yep. And
Yeah.
then database is what?
Same. Craigslist DB.
Craigslist
Init DB.
init DB. That's right.
Yeah.
This should take me into, right,
Mm-hmm.
that database. It does. I run a select star command
Mm-hmm.
from users, right?
Mm-hmm.
Should have 2 people in there, right?
Yeah.
Bob fake email.
Nice.
So interestingly enough, Guillermo, from my computer, when I ran the runner and did the Docker PS, it still doesn't show up. But when I did Docker PS -A, the container actually shows up.
What does dash A mean?
It's showing the stopped containers so that means so it's
All hyphen all
Oh,
stopped and running
yeah,
flag.
right.
Stole your thunder there, Joe.
might be.
No. It's not my B. I meant to steal your thunder. Questions. Ladies and gentlemen, Docker is very, very exciting. As you can tell, I haven't messed. I used to be a Docker pro about a year ago when I was using Docker every day. Now I don't use it hardly because I'm working on a bunch of other different stuff. But super important thing, guys. Notice I'm not a Docker pro, right? But I understand what it is, and I've used it before, and it's enough to get the job done. Make sense? So you are on your local machine. Everyone here is on your local machine, right? But you can create an application within a Docker container that's a different environment, right? Bro, you haven't even got to the exciting part yet. One day you'll deploy those Docker containers on the cloud. And now you're going to have your local environment, then the Docker environment, then the cloud environment. It's going to be like Inception. It's going to be awesome. When you have mistakes, you're going to wonder what's happening. It works on my machine. It works on my local Docker. And then you come to realize, oh, my machine and my local Docker is completely different than the cloud. And it doesn't work there where it should. Don't worry, you're about to run into those problems later on in this cohort.
Thank God, because I haven't run into enough problems so far.
Yeah. So the thing the rabbit hole gets deep, ladies and gentlemen. So the 2 tenets of Linux, honestly, one of the most important things I have ever learned. Thank you, random guy on YouTube, right? Understand where you are and who you are, because right here you're just messing locally and you're messing with Docker, but you haven't even deployed this onto like EKS or anything on the cloud, and that's a whole different ball of wax, right? Yes, what Justin said. All right, guys, I know I just ranted there for a really long time, but definitely practice inserting everything by hand. As you can tell, look into the purge commands. Please be very good. Oh, and I forgot to say this. But in that file, you know how I had to keep putting in the port number and the password? All that stuff can go into the init, right? Get to a point. So after you practice this manually first, right? Run a little bit of it. Notice I didn't even get to the Craigslist thing, right? I did some user with 2 fake accounts. I did first name and an email, right? Start like that. Something very simple, run some reps, make sure you understand what's happening conceptually, right? Then you can actually start building out your schemas, right? And then, you know how the cars DB is all for you? You just run the build command, you run the container, and then everything's populated in there. You can put your port in there, you can put your password in there, you can put your user in there, you can put everything, right? And when you get to real applications, they'll have start scripts, right? And you just execute the start script, right? With the right credentials or the right config, and then everything magically works. I mean, that never happens at work, but in theory, that's what should happen. Make sense? All right, manually first, right? Then with a init file, and then add the ports and everything to the init file. It will work. You don't have to do everything by hand, right? But it's important that you get it by hand first. There you go. Justin just put it, purge Docker system prune. I'm gonna have to actually redo all of this. Yeah, exactly. I'm gonna have to do remember all these, right? And the shortcuts, right? Don't worry, if you end up on a team that uses Docker a lot, you'll be a pro with it, and you'll actually start creating your own bash files that execute everything for you. But again, that's a layer of abstraction. You're not there yet. That's why I don't really like when people use GUIs early on, because if you don't understand how it works under the hood, then it's going to get really complicated when it gets. Imagine trying to learn an application in Docker on EKS on AWS. How do you even explain that to someone? Right? Oh, it's an application. Oh, but it's inside another environment. That's inside another environment. That's impossible to understand. Right? If you don't start from the basics. Right? All right. I ranted for a long time. Please break for lunch, come back, continue. We should get this done by the end of the day or early-ish. I don't know, maybe. Big dreams. Have a good lunch, guys.
After Ooh, are we recording? Are you recording, Adam?
No, I'm
I
recording.
didn't.
Oh, Garrett. You're
We're
recording the
back.
breakout room? Oh,
Yeah.
okay. Gotcha. Gotcha. Let me get back in here. Zoom screen share. Gotcha. Gotcha. Okay.
Wait, are you and me just open micing it right now? I thought we were in a breakout room.
No, I just closed all the breakout rooms.
Oh, okay.
Haha.
How
Okay.
is it going?
Good.
Docker problems still. I'm getting through it.
Okay. I will say this right now. I know we're struggling a little bit with Docker, but Docker is one of those things that is going to carry over into the job, and it's really, really important. Hands down. Just is. You're going to have to get pretty decent with it. It's okay if it's not right now, but you will run into a lot of problems with your projects later on as well in this course. So keep that in mind.
Already.
How far did we get?
We were working on that same problem with that runner 3, runner 4, runner 5, so we're still plugging away on that. But fortunately, I did a little screenshot, so I have a lot of the information. So we just need a little more time to plug through it.
Alrighty. I joined up, Nicole.
I'm still trying to figure out the correct way to connect my category. So
Your
I did it,
foreign keys?
yeah, so I did it first where I have my add table and I added a category option to it to connect it to my category table by the name. And I'm just flipping it the other way now to try to see which one works, I
You're
guess.
on the right track.
Yeah. So I have my add table where I put the add ID, the add name, and then category. And then I created a category table with an ID and a cat name. And I'm just figuring out the correct way to reference back and forth between it because it's going to be from the category to the add, it's going to be one to many. But it was having an issue with it being a unique value or that. So I'm trying to work my way through what that issue is now.
That works. That is the right idea. That's good. All right, guys. I wanted to show you something. I just want to bring you. Do I bother you guys more than the other instructors, or about the same?
Yeah, more.
Good. I'm gonna ask for a raise at the next evaluation. All right, I'm just gonna share something with you that maybe you're not quite ready for, but that's cool. We're gonna let it rip anyway. Can you see my screen?
Yeah.
This is what we have, right? This is what we were working on earlier. I had Bob, fake email, James, butt. Yeah.
Yeah.
All right. Remember I said you could just kind of, so in tech they throw around this word called bootstrapping. Bootstrapping is just all the initial setup something needs before it works, in layman's terms. That's what bootstrapping is. Hey, getting everything that it needs for this application to run, setting it all up and getting it ready. Bootstrapping, right? So right now, I really wanted you to just kind of focus on the manual implementation of these SQL commands and kind of working through it so you kind of get a good, deeper understanding of shells and what exactly you're doing, right? Conceptually, that's really, really important. Ultimately, right, you start building things with a little bit more complexity with all the same commands. Here we have what we were working on earlier, right? What I did was I went into my folder and I just created a bootstrap bash script, right? Up here it says, hey, how's the computer? Hey, I'm running a bash script, right? And we're going to walk through line by line, right? Because ultimately you build scripts for stuff. Like you're not going to input everything manually. That's going to take forever. The one thing that good computers are good at is repetitive processes over and over, right? So let's look at this, right? So, and I tagged them here. Stop and remove old containers if they exist. Why do I want to do this?
Keeps it
So
clean.
yeah, well,
Yeah, keep it clean. Also, if I want to name everything runner, I'm going to have to keep changing it to runner one, runner two, runner three, right?
yeah.
If they're still running. You can't call the container, you can't call more than one container runner within your own device, right? It's not going to work, right? So I stop and remove all containers if they exist, right? This is just a suppression syntax. Hey, if there's an error, I don't want to see it. That's what that is, right? But this says Docker remove. What's the flag F stand for? There's actually a really important flag.
Force.
Force. Force. Hey, I want you to look at any stopped containers and remove them forcefully if need be. Then I'm going to look at the image, at any old images that I have, right? And I want you to remove them too. I don't want any old, if when I execute this script, right? I want you to delete all the containers. I want you to delete all the images, right? Then I want you to build a new image and call it Craigslist DB. Then I want you to run my Docker run command. Not only do I want you to create that image, right? But I want you to then launch a container with that specific image right there, Craigslist DB. Then I want you to sleep. I want you to wait a couple seconds, wait till that loads. And then I want you to exec straight into my database server, right? So I don't have to put all these commands one by one, right? And this last command actually jumps two commands, right? Because I would have to go into the bash script, into the bash shell of the Docker container, and then do one more command to get into my database, right? But this skips all of this, right? So you could easily create a bootstrap SH, right? You can change its permissions and make it executable. I already did it, but I'll do it here just for show, right? Chmod stands for change mode, I believe. Change mode. It just means you're changing the permissions of a file. And X says, hey, give me my ability to execute it, right? So I change it. And if you're curious what kind of permissions the files have, you can go to lsla, right? And notice right here, individually, I now have the X right there. It means I can execute this, right? So I created this, right? So this is what a should I see. So if I run it, get it. Well, let me do Docker PS here. And I don't have anything. No, I do have one. It doesn't matter. I'm about to destroy it and create something else. Actually, I could create this one, right? And now this should be different. So I am going to just bootstrap everything, execute it, give it a second. I give it a sleep for 5 seconds, make sure everything, look at that. Like magic, I'm already in that database shell, Craigslist DB, and I can select star from users. And I have my 3 users, right? But now I can avoid doing all of that, right? This is Jake from State Farm. This is Snake from instead of is it State Farm? I thought it was Farmers. Sorry, I got it. My insurance company's all mixed up. It was from Allstate. Sweet. So notice how before I would have to rebuild the image and run all those personal commands, but here I could just quit, right? Execute my bootstrap, run it again. It's going to run through all the commands, right? It's going to put me right into the shell that I need. I'm going to select star from users. Nope. I forgot my T. Select star from users. Look at that snake from Allstate. I don't have to input everything manually. You're just not going to eventually, right? But if you don't know how to read this, you don't know how to build it. You don't know what's happening. Make sense? The manual inputs are really important because it's all those manual inputs, right, that you start building applications from. Right, so I could actually just drop this in the I'll drop this in the questions channel, and you can create it and kind of run through it as kind of like the final boss, right? Once you've already updated manually, you've messed with it, you've used the init SQL to upload a little bit of data, right? Now you're just working on your schemas. You haven't cut that down, right? Feel free to use the script, speed up the process a little bit, right? And get you to where you need to be a little bit faster. That's just an example. Right, and in real applications, you have, depending on exactly what it is, you'd have like a start.sh script or something, right? Or like a main function somewhere, right? Where this will do a bunch of stuff like pulling, environment variables, authenticating, launching the script, typically a main function or something, or a main class, and it'll get everything going. Questions about what this sh script does?
Yes. So I'm trying to run it, and I got a permission denied. So I know it has to do with my ability to execute that file once I created it inside of VS Code. What's the chmod to enable that? I forget.
ch5 plus x and then file name. It says, hey, give me the permission to execute this file plus x.
Okay.
Just sent it to you. I just posted it in the hotel evening and weekend questions. I don't know why I stopped sharing my screen. I could just was share again. It's this one. It's should show up. Yep, that one. And obviously, bootstrap. I just called that because that's what you're doing. You're bootstrapping the instance, but you can call it whatever you want. Go ahead, Art.
Guillermo, is there a time that you wouldn't want to create these instructions with your password because once it's already in the file, like it could like say be uploaded to say a Docker file that would somebody else would have your password?
Well, here's just for your local machine, so it's not a real password, but typically you'd have a git ignore, right?
Okay.
And in here you'd have something like passwords or something, right? And this wouldn't be and in here you would have like a folder called passwords, right? And that wouldn't be pushed up to GitHub.
Okay, awesome. Thank you.
Yeah, or it is really popular to have like config files in here, config.yaml or something, whatever.
And Guillermo, I actually figured out what my problem was. So it was the commas at the end of both of my tables that I was trying to create.
Okay, that makes sense.
Yeah, and so now I got it fully running and creating the necessary. I'll show you here, if you don't mind.
Disco, go ahead and show me. But what mistake did you make initially?
The initial mistake was this here. So the very last.
I actually wouldn't even take that as your big mistake. Your big mistake is you started with too much
I
data.
started too much. Yeah, I started with too much data. And so I trimmed them down to just creating 5 uh, five users and five user profiles, right? And of course, since you're doing the default or for this ID here, the account ID, which is where I attached this here. So for this, since we're referencing the user ID, when it creates the table, it's going to auto-populate the account IDs for it, right? And so when you're using that and you're creating these manually by hand here, I actually had to go in and I know I was going to use 5 users, so I had to go in and put 1, 2, 3, 4, 5 as their account IDs to match up with the user ID number.
Why can't you just use the profile ID number?
Well, I could, I guess. But the way this is, it's my understanding the way it's creating these 2 tables, right? So the default is just using the default ID number that's automatically assigned as the users are made. So
You can use a profile ID as an account ID. Right here, it doesn't seem like it's a big deal, right? But you're duplicating work right there.
Okay. So here, is there a way, like instead of implementing this, instead of putting these in here manually to match up, is there a auto?
There is. Can't remember how to do it.
Okay, yeah. So that's where.
Right, because right now you have 5 elements. What if you had 100 million?
Right. Yeah, exactly. You don't want to go through there and do them by hand. So
you're not going to do that. That would take a lifetime.
Yeah.
Actually, I think you might, even if you live like 90 years, I think you might die before you could do that. That's too many.
And I got your bootstrap thing to work as well. So that was cool. Thanks for that.
Programming, bro. Programming.
So yeah. That's it. That's what I had.
Awesome. Thank you so much, good sir. Questions about anything that the Cisco covered or that I covered here in this little mini lecture or whatever? I'm going to share a little story with you in hopes to give you a little motivation, okay? I was over in January, a couple months ago, I went to climb the highest mountain in the Western Hemisphere. It's called Aconcagua in South America. It's like just shy of 23,000 feet. At that specific, so I had gone up with my partner around midnight, and we're trying to summit before 2 p.m. At about 10 in the morning, my partner couldn't continue. So I was on myself. I was on my own at about 6,000 meters, which is what, like 19,000 feet or whatever. And I still got a long way to go, and I was behind our hit time. My friend decided to turn back, and I continued on, seeing nobody because I was way late. And I was thinking of turning back. I'd never been on top of this mountain. I'm up really high. It's really snowy. Didn't know if I was going to have to turn back. And if a storm came, which storms had been coming, I would have to turn back. I saw a guy from Colombia come past me, right? And I was like, hey, are we going the right way? This is good. Because I had a GPS with me, but still. And he's like, yeah, just go up. And he pointed me to the direction. So he was way faster than I was. He went ahead of me. Finally, I just kept chugging on for hours and hours. And finally, I got to almost the pinnacle of the top of the mountain. And I started to see people coming back. And I was still going up, and I still had like 4 hours left. But on the way back, I saw the guy, and I was like, "Hey, man, am I almost to the top?" And he just looked at me, and he said, he was Colombian, right? So he spoke Spanish. He said, "Vas a necesitar aguante," right? Which roughly translates to, "You're gonna need some endurance, bro." He didn't lie to me. He's not like, "Oh, you're almost there," and he was right. It took me 4 more hours to get to the top because it was still pretty long from there, especially when you're going one step at a time because you're at like, almost 7,000 meters, 22,000 feet and change. And that's the advice that I have for you. You're going to need a lot of endurance in this field because, believe it or not, all the stuff you're learning is really easy stuff. I know it doesn't seem like it right now, right? But the coding part, and if you guys were with me right from the beginning, right, the coding part's the easy part, right? It's everything else that is hard in programming. So that's a story for you. Van a necesitar aguante. You're going to need some endurance for this one. Anyway, I hope that that was inspiring. Maybe it wasn't. Maybe I just like
What
to
for
hear
me?
myself talk. What was that, Adam?
Inspired me. I'm good.
Let's go ahead and wrap this up. How'd it go?
I learned a lot today.
Oh, you learned a lot. That's good. Where we end up in terms of the challenge? Do we have a functional database?
Still functional without the ads part. So
What was the problem with ads?
uh 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 the connecting the IDs to each other, I think
The foreign keys?
yeah, the foreign keys and whatnot. So just that part of it. I tried a few things, and every time I tried it, it broke. It broke the databases. So or the whole yeah, it broke the database, and it wouldn't completely start up and run. So I had errors that I had to keep going back to troubleshoot. So that's why I'm stuck at.
Okay. Well, where else, guys? Where else did we get stuck?
Just what we talked about earlier today. But yeah, I think the database was working okay. So thankfully not too bad.
Alrighty. Ultimately, when you finish building out the three tables, oh, give me a second. Sorry, I'm loading this. The three tables, your three tables should be users, categories, and ads, right?
Mm-hmm.
And you are going to have, what is ads going to have a reference to? It's going to have two important ones.
To the category ID and the user's ID.
Yep, that's it. That's the crux to the whole thing, right? It's going to point because ads has someone that wrote it and also has a category where that specific ad belongs to, right? Whether it's housing or jobs or items for sale or whatever Craigslist category you got, right? So just going to share the screen with you. Can you see my screen?
Yep.
Alrighty, we're going to do just a little exercise before we wrap this up. All right, these are my three tables, my data that I've inserted. I have my Bootstrap ready to go. So how do I populate my database and log into my database? What am I going to run?
You're gonna do Docker build T.
No.
Oh, you can just run your bootstrap.sh.
Yeah, I can run Bootstrap. That's why I built it. All right, boom. I'm going to build it. It's going to insert all this data. I am purposely not showing you my tables. That's your homework assignment. All right, so now I'm in Craigslist DB, and I can select star from, let's do ads. What am I going to see?
You're gonna see 3 ads.
Okay, let's see. Yeah, I have three ads. I have ID 123. I have three ads for a brand new iPhone 20, a bougie dog walker needed, and then a two-bedroom apartment. It kind of sounds like three categories, and I can see it: for sale, jobs, and housing, right? On line 44, 45, 45, 44 to 47, right here, right? What if I wanted to get give me the query for grabbing items for sale that have the word new in them. What's the query?
You can do select all from ads. And then let's see where description then you have you can do I forget what it's called.
Someone help them.
It's the I'm thinking about the rejects.
Is it the
Rejects.
equal and then in quotes you would do like the modulus new
Yeah.
modulus?
There you go.
This?
Yep. That should work. Yep.
Select star from ads where description equals modulus new. So this
Yeah.
should return my iPhone. Is that what you're saying?
Yeah.
Doesn't return anything. So that's not it. What is it?
Like?
Yeah, like or I like, I think.
Like, yeah.
I like would work too. Because I think that removes case sensitivity.
Description.
Yeah.
I like.
I like, yeah, that'll work.
Doesn't have to. I like.
Mm-hmm.
That work?
That should work, yeah. There you go.
There you go. Grab me only the user's email that posted the iPhone. That's all I want. Grab me the user's email that posted the iPhone.
All right. You want to do select email from users. Email from users. Yeah, yeah, select email from users, and that's all you want, right? So
Join the ads table on user ID. So it'd be on users.id equals ads or ads.users underscore ID where I guess you could do the same with like this description, like I like new for that one. Or
I want you to grab the title.
you want to grab the
So-
what?
I want you to grab the title because I said iPhone.
oh, okay.
So where the title like
Where title like
Mm-hmm.
iPhone.
Oh, you got to do put the
yeah.
modulo.
I like that better.
Yeah. You see where I'm going with it, right?
Maybe before and
Of course.
after, so it doesn't matter where it is.
Yeah, the modulo.
Say that again.
Put it, yeah, but put it before and after the iPhone, so it doesn't matter where it is.
Ah, there you go. All right. So what should this return then?
Hopefully, the email
just-
of the user who has posted
Okay.
that. No? Okay.
Not that was close, right? So let's go section by section, and it'll be the last thing we do. All right, so that was relatively close. Let's go back. I can't remember the shortcut to go back by word, so we're just gonna scroll the way back. All right, so it's select email, right?
Mhm.
From users,
Yeah.
Yes.
join ads. What's wrong here?
Do you have to give ads a designated name or something like that? Or tag?
Mm, kind of, right? But look at the front of this, right? I want to select email from users, join ads, right? User ID equals user ID, where title is like iPhone.
What kind of join is join?
Good question. What is it? You learned this, right? Earlier in the week?
Isn't it defaulted to inner join? Or no?
That's right. So
Good.
what's the syntax for an inner join?
So you need all, right? I'm not sure.
All right, what's wrong with the first part? How about that? Let's take it piece by piece. It's not select email, it's select what?
Would it be users.email?
Yeah, why?
Because you need to identify what table it's coming from.
There you go.
Mm,
Email, I can't find email if it doesn't know what table.
I see.
There could be 1,100 tables. It's not going to find email, right?
Mhm.
All right, so now we're selecting, go to the table users, grab email from, where's my email located?
New users.
Read this properly. Select users email from,
From users.
it's not users. Because what eventually am I going to search?
Ads.
Ads.
Yep. So select users email from ads, right? Join. You join on users, right? Not ads. You had them flipped.
Okay.
Join users on.
User ID.
Is it users ID?
Should be ads user ID.
Why ads dot user ID?
Because you're searching through ads first
Good.
to
Right?
connect.
Yeah, you got to give it the table, right? Users on ads users ID equals.
You need to put an underscore there for users underscore ID instead of dot ID for ads.
Whoa, I got it's users on ads. Oh, yeah. Underscore. Yes, I was trying to figure out what you were saying. Users ID, that's the name of the column, right?
Yeah.
Then ads user ID, right? Where? What's wrong with title?
That'd be ads.title.
Yeah, I need to know what table it's at. Ads dot title, right? And then here we could just go I like as well. I like iPhone. That way the caps don't matter, right? And this should return the person that posted the iPhone.
I think that you just referenced ads user ID to itself.
Okay.
So that
How
has
do I
to be
fix it?
users dot ID instead of ads dot users underscore ID.
Oh, sorry. Say that again.
Switch where you are now, switch that to users dot ID.
Ah, this?
Delete the ads, the front.
That's right.
It's not from that table.
Users ID, like that, right?
Yes.
Great catch. Users ID because it's table users. .id. So this should give us the person that posted the item. Ooh, closer.
Okay. Oh, it's not user's ID, it's user ID in the column on ads.
User ID
Yeah.
and not user's ID. Users is the table,
Mhm.
not the property. Third time's the charm?
No.
Nope.
iPhone does not exist. Column iPhone does not exist. Oh,
That looks right. What's wrong?
it's saying it's a column name instead of searching within the column.
Select users dot email from ads, join users on ads, user ID equals, right? Users ID, where ads dot title, I like iPhone. Oh, this is a really subtle mistake here. Can anyone catch it? This is perfect, actually. There's one really small thing here. I'd be surprised if you get it, actually. This is perfect.
Can you make your text bigger?
Yep. Oh, yeah. I need to do a better job with that.
Does capitalization matter on your titles? Like I like?
No, it doesn't. But the issue is here.
Oh yeah.
Oh, yeah. You didn't have the quotation marks over it.
I always forget that because of T-SQL.
Yep. I thought it was perfect. I thought we had it on its right, and I had to look at it. But yeah, easy to forget. Small nuances. So that's what everything we just did. You should be able to do once you create your own Craigslist table, just like that. And you could literally make up the queries. You could practice like that. But like the ones that I gave you, I don't. It's not written down anywhere. I just thought of something. Knowing that I have these three tables, I was like, find whatever, and you can do it to yourself too. Make sense?
Mm-hmm.
I could have done, run the total sum of all items for sale across the ads table, right? Right. Return only items priced less than $300 because that's all I have. Right?
Yeah.
Okay. Cool. I'm gonna stop sharing somehow. Did I stop sharing already? Oh, oops, sorry. I was literally just showing just the where I inserted the data. Okay, so that's it. If you didn't get to finish this one, I would highly recommend you take a little bit of time. I mean, definitely break for dinner. Take a little bit of time and run through it. And you don't do like two items. Do like two items. But because this will come back to dropping the table, the inserting data, it will come back for your personal project and your group project because everything's on Postgres
Can I
when you
add
build.
one thing?
Yeah, go ahead.
This is a great time to do what ChatGPT is good at, and that's creating junk data. So use it to make, like, if you want a bunch of things like users or your toys or whatever you want for your ads, make one and say, make a bunch of these fake ones so I can just copy and paste it in. That'll save you a bunch of time.
123 Fake Street.
Yep. But ChatGPT is really good at fake data.
Yep. Questions before we wrap up? Oh, crap. We're about to be over by a minute. Guys, have a wonderful Saturday. Don't give up. We need endurance in this journey, okay?
All righty.
Have a good day, guys.
You got it.
Hey, guys.
Bye.
Bye.